you go from architecture to schematic in 60 seconds.
From EE Tech and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. Today in the lobby, I'm joined by Tomide Adesanmi, co-founder and CEO of CircuitMind, who is taking an algorithmic approach that automatically creates circuit schematics based on design requirements. I really love their pragmatic and realistic approach to this problem of designing schematics, and I don't want to spoil too much in the intro, so let's just get right into it. Tomide, thanks for coming on. I'm very excited to have you here.
Very excited as well. Thanks for having me, Dan.
I'm curious, how did you first get into technology and engineering?
Yeah, so, I started very young, loved maths, loved physics, went to university to study electronic engineering. And that's when, I started kind of writing software, building electronics for my degree. I used to kind of hack things during my university days, my secondary school and university days, and started building startups at the time.
Do you have any favorite hacks that you had in college?
Yeah, there were quite a few that I worked on. One of my favorites was a very early version of a sign language glove. So a glove that you could use to kind of sign, and it would use an Arduino to interpret the kind of movement of a person's hands and fingers, and then convert that into letters on an LCD screen. So that was a very early version, one of my favorites. Another one was this Wii controller that kind of allowed, there were two versions of it, but it started with the Wii controller, but then I moved it to something called Q&A. So it became an app where a university professor would ask questions, and then you could go onto a website and kind of answer the questions. I started by using a Wii controller to kind of answer questions. So it was quite interesting.
That's fun. Yeah, the Wii controllers are surprisingly versatile for that sort of thing.
These were they weren't the Wii controller. They were like chip versions.
Yeah, sure. And you said you also did some startups in college. Is there any standouts there for you?
Yeah, so Q&A was one. So this was the question and answer app. Another one was food delivery startup in my home country, which is Nigeria. I did I don't know if you know Checks. It's kind of
it
like
rings a bell
for kind of uploading books that people will kind of pay a small fee for, borrow, or sometimes use, kind of read for free. But these were university textbooks. So I did that. And then when I kind of started working at BAE Systems, I also had some side projects like Viewports, which was for finding videos in different geographies, and also building these kind of LED cubes, 3-dimensional LED cubes, 8x8x8, that kids could use to learn to program, actually.
It seems like you've always had kind of a entrepreneurial thread that I want to pull on in a moment, but what was your first job out of college? You mentioned BAE.
Yeah, so my first job, I actually started working in BAE when I was in university. So I did an industrial placement with them, and then I started working at BAE once I graduated. So I had a job from them already. And so my job was, I was an electronic systems engineer. So I was working in their electronic systems division, building helmet mounted display systems and heads up display systems for jet fighter pilots. So, the HUDs and HMDs that we built on kind of a lot of the popular fighter jets that you hear about. I spend most of my time in my career doing that.
That's pretty cool, working on fighter jet systems.
It's very, very interesting. I mean, there's a lot of process. There's a lot of kind of safety related stuff. So I think one thing I like to say is I got into electronics at this sort of very extreme end of it, right? Like where you have a lot of structure, you have a lot of bureaucracy, you have a lot of some safety criticality and high integrity that you have to take care of when you're doing a design. So I got in at that end. And I kind of had to work my way back out of that.
Yeah.
When I came out of the sort of more industrial world.
Yeah, aerospace doesn't have much room there's not a lot of wiggle room.
Not a lot of wiggle. You have to get it right. and you have to have sort of high integrity in terms of the platform doing what you say it's going to do to a very high degree of accuracy all the time.
Are there any highlights from your time at BAE? Any favorite projects or moments that you can like share a story of?
Oh, I have a lot of them. I think my favorite project was a heads-on display system because I spent most of my time doing heads-up displays, which are very well understood in the aerospace and military domain. You kind of build at the next generation. So we were building the next generation with what we call digital light engines. Basically, we're turning a lot of the analog stuff into digital. And I also worked on helmet mounted displays where we're doing something similar. Also worked on the early generation of the color version of those HMDs. But I think the most interesting was the project where I could be more versatile, and I was already coming into my own as leading the systems parts of projects. And so this was why we're building a head-on display. So this was very innovative. It's not something that was done. You don't see pilots wearing glasses or goggles to kind of fly a plane. So this
Right.
was kind of experimental. So I think interestingly, the more exciting parts were the portions where I could innovate a lot. I didn't have these kind of shackles of the requirements, etc. We just had like green field to kind of play with new ideas. Optics was brilliant. The small form factor that you have to get with the electronics, all of these sort of elements that you can see in these sort of new age augmented reality products where, battery life, etc., they were a concern. So that was probably where I started to do my most innovative work before I left BAE.
When you see things like the new Oculus headset come out or the Apple Vision Pro, as someone who's done this on a very high and professional commercial enterprise level, what's going through your mind when you see these consumer grade products come out?
You can probably keep me here for like a couple of days. That's my shame, right? Like that's kind of one of the things that I spend a lot of time thinking about. If I walk back, I mean, when I first came out of BAE Systems, I would say I looked down on the sort of commercial grade projects for various reasons. Obviously, because of the sort of high integrity you have to reach, the high end requirements you have to meet. The way I think about it is that my first pet peeve, little pet peeve, is I always want to separate virtual reality from augmented reality. That's something that I really, really care about.
Fair.
I don't like people bringing up the Oculus when I'm talking about virtual reality and so on. So the first thing to know about the way I think about these things is that I believe in augmented reality as the vision of the future, that you will be able to walk around and you will be able to overlay your field of vision with all this information that interacts with it. And I believe in that vision of the future. I'm not necessarily like a big driver like virtual reality where you escape out of the world. Although I believe that that's going to be a big market and so on. So I care a lot about the augmented reality. And within augmented reality, in this world, we always thought about optics-based augmented reality rather than video-based. One of the incredible things that I saw with the Apple Vision Pro was, I think the Apple Vision Pro made me believe in video see-through AR, just the thought they put into how quickly you have to be able to kind of process this information, overlay it, all of the eye tracking. It kind of makes it sort of work. And it's something that I haven't given a chance before. So I think it's like this year, or late last year was the first time I started believing that this was probably going to be possible in a useful way.
Yeah.
And there are other reasons why I kind of liked the vision of the future that Apple kind of brought out. I mean, I don't think this is a popular opinion, but like they surprised me with some of the issues that the accommodation conversion convergence problem, all of these problems that they kind of managed to tackle. I thought was very fascinating.
Interesting. So how did you go from BAE, big, enterprise aerospace defense, back to startup land?
I like to say I got tired of reading data sheets, so I kind of ran out. No, that's I think at the time I was building electronics in my day job and also writing software in my personal. So I was building an app on this as a side project called Viewport, and I was CTO of that company where we're building that up. But I think that combination of building electronics and seeing what you could do with software, building electronics first, doing electronic systems, which was a lot about the kind of high level and bringing everything together, and then also writing software. Some ideas started kind of going on my mind, because one of the big problems I had was that I wasn't spending a lot of my time on the most innovative things. You grow up as an electronic engineer trying to kind of think about being like Tony Stark or something, and then you go into a company and you're kind of on Mauser and DigiKey half the time, and you're in the spreadsheet trying to reconcile sort of power analysis values half the time, and you're drawing symbols sometimes. I would say probably 60-70% of the things I was doing, I wasn't like, I absolutely love doing that. The other part of this was that it was a bit of anxiety. One of my pet peeves in the design process is really the fact that you could be incredibly smart, incredibly detail oriented, and still make silly little mistakes because, page 243 of datasheet of this micro said in this mode, you have to kind of short these 2 pins and, put some, bypass capacity, whatever, right? It's not
totally
how smart you are, or even how detail oriented you are. In many cases, you just kind of make some, there's something that goes wrong. And so you have this like little anxiety every time you are sending something over to the manufacturer. And I didn't really like that. And there were other, sources of anxiety in the process. So the reason why I left was exactly to start to kind of see if we could solve this problem using good software, good algorithms, and electronics. And what I didn't realize at the time was I didn't really have all the skill sets to kind of, tackle the problem and solve it and actually conceptualize a solution properly. But it's good that I found my co-founder, Basilia, because, I just quit. I had already just quit my job and joined an accelerator to try to solve this problem. Actually, I started with a layout problem.
I know you didn't end up on layout, so I want to get into that transition, but first, it's time for a quick break. This episode of Moore's Lobby is sponsored by Silicon Expert. Today in this podcast, we're going to dive into the complex world of datasheets, and there's one company you need to know, Silicon Expert, bringing you electronics market insights at scale. Silicon Expert gets a direct feed from suppliers, gathering datasheets and product change notices daily. That means you get up-to-date info from over 22,000 suppliers and 1.3 billion electronic and electromechanical parts all in one place. Right now, they are offering a free 7-day trial of their Silicon Expert platform, which will help you get part recommendations, assess your bill of materials, forecast your supply chain risk, monitor your compliance regulations, and more. Say goodbye to your spreadsheet full of datasheet links in your file folder full of PDFs, and say hello to electronics market insights and data-driven decision-making. Go to siliconexpert.com and get your free 7-day trial. Again, that's siliconexpert.com. Now back to our conversation with Tomide Adesanmi, CEO and co-founder of CircuitMind. So Tomide, you originally started focused on layout, but I know you didn't end up there. Can you tell me, where did you end up and what was that journey like?
When we first started, the easiest thing to think of when you're thinking about how do we, take electronics design to the next level is author, right? We say we just need better auto readers. But then if you take a step back, just think about the problem a little bit, you find that auto routing, while it's a worthy kind of problem to attack, you kind of don't have everything you need. You don't have all the information you need to build really great auto. So you don't have information on the constraints. So I had some people at BAE, they do the layout team, but some of them would swear that they could get the auto reader from the DS designer, so mental graphics expedition and DX designer, those are high level tools to do a great design, but they'll probably have to spend like 4 days putting in constraint. You know what I mean? Like they
100%.
their job would be like the just doing the constraint. They swore by it that auto routing is fine. So the problem with auto routers, to me, wasn't that they weren't good auto routing algorithms. It's like they just don't have the data. These CAD tools just give you, like shapes, and then you have to add a lot of information to that. So we stepped the back of it and, drew from my background in doing electronics engineering and electronic systems, my co-founder's background in building algorithms. So he has 2 masters and a PhD in algorithm design. And our bet was that you could build a system where you could start from the front end of the design process, where you're selecting, you build your block diagram, you're selecting components, you're connecting them together into a circuit, checking for compatibility, doing your analysis on cost, size, power, etc. And you could help an electronic engineer to generate some parts of their design starting from that block diagram. And so what we do right now, what CircuitMind does is we built an engine that helps you go from architecture to schematic in 60 seconds. So you can specify your requirements as a block diagram. You can specify lower level requirements on each of those blocks. So, on a memory block, you can specify that I want my memory size to be greater than this. Or on a microcontroller, you can say I want from a microcontroller from ST, or I want a specific part number. But once you specify all that, you can click a button, and our platform, using our algorithms built by PhDs, ex-professors, can look at billions of combinations of potential design options, automatically generate a bug, automatically generate a schematic, optimize it for cost, size, power, all in 60 to 600 seconds, a minute to 10 minutes. And it's going to be doing some parts of your design for you, obviously not everything. But this becomes a partner that you can trust to do some parts of your design, and then you do the rest. So architecture, schematic in 60 seconds, that's kind of what we're focused on. And also to schematic verification as well. So that's a really key part.
Yeah, I was talking to a friend like 2 weeks ago who does a bunch of layout work.
Yeah.
And we were talking about the idea of AI as part of circuit design and board layout. And he was saying exactly the same things you just said to kind of verify. Like, if you want an auto router to work, you have to type in and figure out so many constraints to put in place the rules for the auto router. And once you have the rules in place, it often will route fine, but how much time did you spend, digging through data sheets to figure out like pad sizes and tolerances and all of that?
That's exactly the problem, man. When we think about the future and helping with the auto routing thing, then at some point, we're squarely and 100% focused on that front end. So block diagrams. But what we believe is that an algorithm can generate your circuit, your initial circuit, like your functional circuit and your schematic. It can also generate all the constraints because it has to have had all the data needed to generate your constraints when it was generating the design. So now you can actually build a good end-to-end flow that includes a auto router if you have a computer automatically generating your circuit, because it has to have all this fundamental information, which is where we spend a lot of time. What's this fundamental information that you are reading in a data sheet that a computer should be able to have access to? And, that's kind of one of the problems that we solve at CircuitMind.
The question that has to be going through people's minds is really like, how good is it, right? Like, how much is does this still rely on you as an expert in the space to like use your judgment and history? I guess what I'm asking is, how much is it a tool that helps you get from A to B, and how much is it like a driver where you just sit in the back of the car and don't have to think about it?
No, that's a great question. So at the moment, it's not a drive. You're the maybe you can call. I mean, I don't want to say a co-pilot, but it's not really a co-pilot in the sense that you would think. It's not like you're writing stuff in ChatGPT and it's kind of hallucinating and guessing stuff and so on. But this is kind of think of it as a solver, like MATLAB solver. It's solving for a circuit. Now, where do you come in? There's few ways I think about it. I say there are three types of or design problems that you want to be that you'll be working on: routine, creative, and experience based. This platform is focused on the things that are more routine. And so routine is like, oh, hey, I need to know all the connectivity of this component and see all the permutations of how it can connect to another component because I have to connect to all these things and there must be enough space. And I need to check all these things. What are the voltages on the page? Do I need a level translator? What are the put-downs, the company level translators, and what regulator rails do I need? That sort of thing. You don't like that's routine work.
Yeah.
What creative is now I need to build like an amplifier or waveform generator. What topology am I going to use? There are a lot of sensitive things in this particular scenario that I want to kind of figure out. That's creative. New things, more sensitive things, etc. And then there's more experience-based things. So more experience-based. I'm an automotive design engineer, and because we need to meet some sort of automotive regulation, I need to make sure that I have over voltage protection, reverse polarity protection here, ESD surge protection to the kind of, for EMC purposes and so on. Those sort of insights are things that you had because you are an experienced person, right? And you don't want all those I call them last mile things. You don't want all those last mile, either architectural things or last mile things. You don't trust something else to do that. So you become this architect, this person infusing their experience and doing work on the creative things. So architecture is one of the things that I hope that every electronics engineer's work kind of focuses on. Because within our platform now, what you can do is you're the architect, you do an architecture, get a quick answer, generate the design. Okay, this is going to be my ball, my power, right? This, still all of that stuff for you. I might need to add change the pull-up value here because the data rate is a bit higher or something. But this is roughly going to be my circuit I'm going to take forward. But let me go back and change this part of the architecture. Let me see if I want my one chip that does Bluetooth, Wi-Fi, and micro. Let's rerun that. Okay, maybe I want something maybe more cost optimized or power optimized. Let's rerun that. And you can generate like 10 different options and you're just kind of playing around now to see what best suits your needs. You become that architect. That's where I want kind of like the electronic engineering sort of profession to go.
Agreed. I when I look at AI, I see it like for more than just circuit design, for the large language models and image generation, it's a tool to help us execute the vision we have as not AIs. It's not necessarily a do it all for me, press a button and walk away sort of thing. We're just maybe we'll get there someday, but right now it's such a powerful tool to help us do these things a little better, a little faster, and sometimes with a little more rigor.
Correct. And the thing that doesn't make ChatGPT or LLMs work, directly in the electronic space is the fact that this is an engineering task and you need precision and accuracy. So you need a trusted party. What we've kind of focused on is the circuit solver algorithm that can give you precise, accurate answers and also do optimization. Give you the best answer, ideal answers, given the inputs you give it, right? What's the most cost optimized thing that I can do with this? Gives you an answer. Okay, what if I said it was size optimized? Yeah, but the cost is a bit too much. What if I wanted to make sure that parts are in stock? Well, I'll choose these, but your BOM cost is out. it has to be accurate. You can't kind of play around with,
Right.
unless it's useless in this case. And it needs to know all the other circuits. You need to know you have a pull up here, a pull down here, unless it's imprecise.
And those sorts of trade-offs and design decisions are things that to do accurately historically took a ton of time and an incredible file architecture of data sheets on your desktop. So to be able to move that slider and just see what comes out sounds really useful.
That's one of the things that we got in, like the biggest. Like I didn't expect that. Like I was building. We started the company to build something to solve circuits, but the optimization became one of the biggest value propositions because nobody can really do optimization today. Like nobody's, your boss is not gonna say, "Hey, go and do 3 different circuit variations, and
Right.
let's compare them when you're done, and then let's see which one is we want to go forward with." There's no time to do that, and the way the engineers, or at least myself, I don't want to put this on anybody else, used to optimize was kind of, okay, do you know what? I'm going to first start by choosing this microcontroller. You just remove a whole lot of possibility there. And they're thinking, what can then connect to this microcontroller? And there'll be a bunch of things that can't just because you've kind of down selected to one thing. And then you go down this path. Still a useful path, but it's not all the potential paths you could have done. The point with an algorithm is that if it can read the information that you'd be reading in a data sheet, it can go through all these paths, all these paths. So right now, with the components we have in the platform and our algorithms, the number of combinations that we look at when you're generating every single design you're generating is all the grains of sand on Earth times 100.
Goodness.
So no person is going to meet them.
Yeah, it's kind of like the if you've seen the movie Everything Everywhere All at Once, where the decisions you made in life have gotten you to this one point, but you can then snap into a different life where you made a different decision tree.
Yeah. You're making sure that you're going through all the paths. That's neat.
It's kind of an I know kung fu moment. Can you walk me through the flow? Maybe pick an example design and just talk me through kind of, hey, I want to do this thing into now I have this thing.
Yeah. So let's say a very good example, which was actually done on the platform, was a smart sensing industrial unit. I think it had 2 microcontrollers, it had a bunch of sensors, it had a motor driver, some displays. If you're building something like that today as an electronic engineer, where do you start? You start by kind of sketching out your block diagram. Some people will sketch out their block diagram in Visio. Some people will sketch it on a piece of paper. Some people might use PowerPoint. And one day that's going to be lost, right? Like, let us to build you the schematic. Like, let's jump in,
Yeah.
So that's one piece. So you start playing there today. What we say is start playing that same thing, but in our platform. So in our platform, you just go and the interface is like Visio, but created specifically to fit an electronic engineer's needs. So you can create a block diagram that's focused on creating a block diagram of thinner electronics circuit boards. So on the left-hand side, you drag and drop a microcontroller block. You drag and drop another microcontroller block. You drag and drop an accelerometer, a gyroscope, a flash memory block, a connector for your LCD, a motor driver, and then a connector for that motor driver. And so you kind of drag and drop these into kind of this block diagram canvas, and then you connect these blocks together with a line. So, indicating the connections. Now, you don't have to specify that this line needs to communicate via I2C or this one via SPI, but you can if you want. So that's the philosophy of the platform. The philosophy of the platform is it's not a very high level, and you can go down into kind of the details if you want, but you can stay at the high level, and it makes choices for you if you stay at the high level because it knows fundamentally the data about how all these components can connect and all those potential permutations in which they can connect. So you can draw these kind of lines, and then you can also specify lower level requirements on each block. You want granular control. So for instance, in this case, you might say, And you can might click on your accelerator, and then you'll have these lower level requirements you can specify as filters. So there's a long list of them for each block. So for an accelerometer, you might have, I want the axis to be XYZ axis. So you can select that. I select XYZ axis, and you have that. You can say for the microcontroller, I want this one to be from ST Microelectronics, or I want this specific part number. You can specify that, or this kernel architecture, or this HCU series. It's whatever level you want to specify. And so you put all this together, click a button, and you start waiting. Now, while you're waiting, you don't actually have to wait. You can just go back and say, well, in that first design, I didn't actually move the trade-off sliders. But there are sliders where you have size, cost, and power, and you can just slide cost up to 100% and regenerate a design. Click a button again, and it's going to generate another design in parallel with the one that's generating. So you can just pile up a bunch of different software lanes of different design options that you want to generate. And then it'll take you a minute to 10 minutes for each one to finish. And then you can compare the results in a table. This one has this power, this one has size, and this one is 20% more, this thing is 2x. So you can compare this and then iterate on the inputs until you get to the final results that you really desire. And this full process shouldn't take you more than 20 minutes. And then once you're done, you click on each of the results you want to take up, and then you'll see a summary. You see your hardware design, so your schematic. So it's selected components, connected them together, added pull-ups, pull-downs, coupling, level translators, all of that, ready for you to export into your design. So you get your BOM, you get procurement information. So procurement information is what distributor am I going to buy it from, at what quantity, what's the quantity available, you get that. You get detailed verification checks. So it checks and makes sure that the design is correct. A separate engine checks and makes sure everything is correct. So we also help to prevent respills. And then you also get engineering notes, which are telling you what assumptions that the solver made, so that you can take that design forward. And once you're done, you export into your eCATL, Altium, Orcan, Add, whatever you have, and then you can continue your design. So that's kind of the workflow using the platform.
It sounds really nice. I like the idea of engineering notes that give you insights into the design decisions that were made. That feels really useful.
Yeah, very useful. And I think because what we do is focused on professional electronic engineers. So it's actually critical. Like it's something that they can't do without, because, we generate your design and we'll we'll create your I2C buses, and we have to choose addresses that don't clash. And we have to tell you that, well, this was the address I gave this component, and this is how we set that up.
Yeah.
How do you know that otherwise, right? It's got to be able to tell you these sort of things. Or, I set this up with an internal pull-up. So because this is going to be used by professional engineers and they're going to take it forward, they might disagree and they might do something different. And that's what I say is that last mile. The engineer still then needs to say, "Oh, I want to take your kind of, thing that you did there, or do I want to change it?" But the good thing is these last mile changes don't take that much time.
Right. You've gotten the first 100 miles or whatever it ends up being. Yeah.
Exactly.
Interesting.
Exactly.
When it comes to like training and inferencing, how are you training models? And you've been doing this since before ChatGPT exploded onto the scene. So that had to be an interesting time as well.
Yeah. The first thing to mention is that we're not using machine learning. That's the first thing. So what we call this is deterministic AI, but these are mathematical algorithms. The reason that what we believe is that when you're building something for professional engineers in this space, again, you need precision, you need accuracy. You can't just say, maybe this is something that works, right? You have to have precision, accuracy, and so on. So what we do is we are building mathematical algorithms that are deterministic. And deterministic means that we can explain how they come up with the circuit. we can tell you exactly how they came up with the circuit. They can be replicated in the sense that if you give them all the same input, the same component database on the same day, because same day matters for procurement information. They will give you the same thing. So they're deterministic in that way. And so what they do is we spent a lot of time doing with PhDs and professors, these are mathematicians, and we spent a lot of time building algorithms that could solve for a circuit given the digital model, for the digital twins of an electronic component. So what you should envision is anything you can read in a data sheet, that's been extracted and modeled in a digital format. All the potential combinations of how all the connectivities that a component can have, all the configurations, the attributes, all of that are now existent in a digital model, and these algorithms can read, understand, and generate a design from.
Have you become a connoisseur of data sheets now?
Not me myself. I think some of the people, some of the guys on my team are just like they're probably the most. I would say they're the most experienced people I feel for reading data sheets, because it's actually some people's jobs to just read data sheets at Circuit Mind. Like, I'll take that back and just say that what we are experts at is figuring out how can I generalize a model for a certain type of component and look at a data sheet and then fit it into that.
Interesting.
That's kind of our expertise. So we try to really, really understand the nuts and bolts of components. And there's a lot of automation in that as well, in understanding that and creating those models. But there are always people checking and so on and so forth. So
Yeah.
we are, I would say, the foremost connoisseur, because I don't think there's anybody else doing that, right?
Interesting. So it's like, what is the essence of a level shifter? What makes a level shifter, and what are the different parameters that might feed into this?
100%.
And then when someone comes out with a new level shifter, you just say, "Oh, this fits into our model."
Yep.
Plug in the things, and we're good to go. Interesting. That makes so much sense.
Correct. And sometimes you have to evolve the model because someone comes with the nuts, the crazy ass level shifter.
Yeah.
Well, you're like, oh, that. Oh man, we didn't think about that.
But that's how we are. Like our brains. Like I have a mental model, a mental twin, not a digital twin, of what a level shifter is and does and how it operates. And I have to, when I'm looking for a part, have to fit that into my, worldview of level shifters.
Exactly.
And I can almost offload that. Yeah.
Exactly. And something comes along and it's like, oh, that's doing something that I haven't seen being done before. And, I now have to update my mental model. Or I need to say, well, this is a special case. And I really need to, update the model in that case. Make a new model for a new special case of level shifter.
So you mentioned you have people on your team who are essentially just like ingesting data sheets. Can you describe the team at large and how you view your role as CEO, especially thinking back to how you did some strategy work at BAE, and I'm curious if that kind of ties into what you do today.
Yeah, so the team is mostly engineers. So we have the idea of why Circuit Mind can be built, I think, springs up from the team that we kind of focused on building. We built a team with three types of people. Electronic engineers, because the electronic engineer is the person that you're trying to replicate some of the task they're doing. And that person in our team infuses that information into the rest of the team, or those people. It's probably now almost half the team is electronic engineers. So that's one. The second is software engineers, because they have to build the vehicle with, that people can use to use the platform. And then the third is algorithm engineers. The algorithm engineers, these are these mathematicians that solve the problem of how can you solve a circuit, right? So my co-founder, for instance, is one of these mathematicians, and he's got a PhD, and we have a professor from McGill. So, and then we have our commercial director was chamber, sales leader in ANSYS, and so on. And he has a research career. So the team is primarily made up of engineers, electronics, algorithms, and software engineers. And then there are some, like ops manager and say other commercial director and a BDR, business development rep. So, and at this point, we're about 20 people. So it's not a very big team, but it's a core team that was built primarily to make a specific breakthrough in the electronics industry. And you need kind of like a core team of people who are always kind of, think of it as like a three pizza team, like around a table trying to solve hard, complex maths and other problems together, and electronics problems together.
Yeah, it's an exciting time to be able to have the compute power and the cultural momentum to adopt something like this. But when I talk to engineers about this type of platform, from the whole PCB design process, from implementation, design to layout, I'm almost universally met with skepticism.
Yeah.
Can you tell me about some of the folks you've interacted with who were maybe originally skeptics and have come around, and what about the platform brought them around?
Yeah, so I think that electronic engineers are rightfully skeptic because of history. So
Yeah.
the auto router, I mean, there's shirts that say auto router suck. Like, I mean,
Yeah.
but someone be so passionate about a piece of software that they create a shirt about it. It's so negatively passionate. Like that's kind of bad, right? So that is you gotta sit down and say, well, that's well deserved, for the software community or in the EDA space. So that's one. And then number two, I also see that they're rightfully skeptic because there's not enough thoughtfulness put into problems that you can actually create a lot of value. That they can solve to create a lot of value for electronics engineers. So, someone might just say, okay, well, I'm gonna take Chat GPT and use that to suggest components for you and so on. And I test it, but you want people thinking harder for you, right? So what we tried to do was, just alluding to my kind of prior statements, like we wanted to start this company with electronic engineers. Like you guys are doing, these are experts in the thread. So they know what the electronics engineers need. They can talk to electronics engineers, they can understand electronics engineers. And then we wanted deep, comprehensive solutions to specific problems that could add value. So we do get, we get people coming into a demonstration with Second saying, I'm curious, I'm skeptical. And then they leave us saying, wow, I'm very impressed. And so now we have dozens and dozens of customers across automotive, EMS, etc. Story of one guy who started and said, look, I'm just going to give you a chance here. But my goal is I want to double the number of projects as a consultant that I'm doing with my customers. And a couple of months in, when he had done a couple of designs and checked the results and it was working, he goes to his customer meetings now saying, my value is that I can get you your schematic in 2 days.
Mm.
Like he leads with that.
Interesting.
Right?
Yeah.
And so now, and he's an engineer, he's a consultant, owns his own business. He's relying on, like, that's his work to his customer, right? And we have dozens of this across small companies, large companies, etc. But another piece that I like to say is we're also not starting by trying to convince like the person who's ready to kind of chill. You still have to give it some leeway. You still have to say, yeah, let's start off somewhere and get some value somewhere. Usually I find today, the biggest place where people start off and say, this is definitely going to give me value, is the optimization, solution exploration, comparisons, getting different options, like getting to something that might have been better than what they would have done if they just went in this sort of heuristic path. And maybe they can decide, okay, maybe I'm going to use the schematic or not. Like maybe I'm going to draw my own schematic. I don't know. I don't like how you utilize. And people come around to that later on, but where they start is this capability they're not doing today, right? That's the key. The capability they're not doing today is where a lot of people start to get value.
Especially as someone like that consultant who is probably very good at that last mile, but being able to get to lots of different last mile solutions quickly is hugely valuable.
Yeah, and he's also spending his time trying to get new clients.
Yeah.
So think of it. So he's trying to get new clients. He's trying to, kind of do the designs. He's hiring more people. It's just a bit of a pain, right?
Yeah, I don't envy that role.
Yeah.
Where is this going? So you've been doing Circuit Mind for 5 to 6 years. Does that sound right?
Yeah.
What does this look like 5 years from now? And what does this look like 25 years from now?
Yeah, so I think within 5 years, about 4.5 of those were just R&D, just pure. How do we kind of put a comprehensive solution to this problem that actually is usable by a professional? And that's a very hard problem. And so there's kind of more that we need to do. So today we can do parts of your circuit. 5 years from now, we want to do more parts of your circuit, right? So there's so much in our roadmap that's actually just mind-boggling. And so we want to just keep on trying to build, kind of things that can solve more and more of an engineer circuit, so that they just get those routine things. So that they just spend most of their time on creative, experience-based tasks and more enjoyable tasks. And they can also be these architects. So that's kind of where we're going. So 5 years from now, 25 years from now, I just feel like there should be a world where we start from professionals, but we also want to go, to others after 25. The way I think about it is that the best way to build something useful here is build something a professional would use. And that thing a professional will use, a maker, a hobbyist would also use it. I mean, a 5-year-old would also use it if you kind of improve the level of abstraction. But it's not the same the other way around. Like if you're doing something for a hobbyist, I don't know necessarily if professional might find that useful. So we will build for the professionals, but then 25 years from now, we want anyone to be able to come in and say, I want to build something. Obviously not as well as the professional. They can't interrogate it as well as a professional. They can't iterate. They can't do that last mile as well. They can't, do all those things, but they should be able to build basic things, a nice, IoT prototype that they can just, hack together and, get the PCB, the next thing by Amazon Prime. And we kind of also want to have this vision of linking together the supply chains in such a way that we can do a lot of the kind of just have this cockpit. You go and put your block diagrams and we can do a lot of heavy lifting behind that for you. But that's kind of a long way away. Right now, it's how can we help professionals with their work? Okay.
I love that. I think that's the right approach to just not only from a functionality standpoint, but from how do you build longevity and find longevity as a platform. Like that's how you gotta live. We're right near the top of our time here, so we like to do some lightning round questions at the end of every episode. First question for you: if you could wave a magic wand and automatically either include or change component data sheets in some way, what would you do?
Oh yeah, I would make every data sheet our model. Just write data sheets as our models, and nobody has to read anything ever again. Now, you just automatically. So, yeah, that's it.
There you go. That's a good magic wand. It sounds great. Who writes the best data sheets, in your opinion?
Well, I think I'm not actually the best person to answer this question.
Okay, that's fair. We'll cut it.
Peter. Peter will tell you.
Okay. Oh, Tomide just went on mute and he's asking Peter.
Peter said TI.
Okay, Peter said TI.
The guru said TI. So
okay, next question. In the world of pop culture and media, are there any people or books or movies that really get the world of engineering right in your mind, or any books or movies that really get it wrong?
I don't think it gets it right, but I think the most interesting, like one of my favorite books right now, that was a very unique blend of science and engineering. I kind of opened up my wonder to science and engineering was the three-body pragma.
Hey, yeah.
And yeah, it's a really good book for me. I like the blend of science. I don't think it's accurate, but
You mean you can't change the background radiation of the universe?
very wondrous, I would say.
Wonderful. Wonderful. What advice do you have for people who are starting to get into the circuit design space or the world of engineering at large?
You want to be one of two people. You want to either be a generalist, someone who can build, be a great architect, build things end to end, and almost treat, different tools and future AIs, because they're coming, deterministic AIs, different tools, treat them as agents. And you're this sort of, again, I don't want to repeat it a couple of times, but I think it's a perfect description. Like, you're this sort of Tony Stark type figure who has so much knowledge about all these different types of engineering and can just put something together with these agents helping them to kind of create like a holistic picture. So that's going to be a really powerful engineer. I think the second type of engineer that I think is going to be incredibly powerful is a specialist, a deep specialist that can do the things, that sort of the last mile, where the last mile is the most critical. The RF engineer, I don't know, the engineer working on the most sensitive things. However, he knows a lot about automotive and automotive designs and the regulations and all the stuff to make sure that that circuit is reliable. Um, those two sort of ends of the spectrum are going to be the most powerful, most well-paid, and the most fulfilling, careers in the electronics and engineering space in the future, in my opinion. But that's just my opinion. I spent some time thinking about this, and I think this vision of the future of either one of those is what I want to empower engineers with. Leave all these things, focus on those specialist things that you can be great at, or use this to just be like a source of,
Yeah.
free,
Yeah.
buried and change things, automate, iterate,
Yeah.
and just be much better, faster at creating value.
Yeah. I love that. Last question for you, and maybe it's not a lightning round question, but I love moments of discovery and moments of like maybe validation. Was there a point along this journey for you where something happened or something clicked and you went, oh my gosh, we did it?
Oh yes, 100%. The first time someone was doing a trial, early last year, so was doing a trial with us. They export and they generated a few designs, exported the design. They were doing a trial to benchmark against another design that they did the trial, exported designs. I said, you know what, I'm gonna build that. And this is all I need. I know, like, this is all I need. I just need the circuit. And you gave me the circuit. I was like, wait, what? I was like, yeah, I'm done. I've got my circuit and I want to go build it. And they did end up taking that forward. But I think that was mind blowing for us. And that was like a I think it's gonna be one of the most memorable moments in our history. That was the first time someone took a design and just kind of flew with it.
Yeah, like it worked again better than their benchmark, and they used it.
And they were just like, that's what right? That's what I
Yeah.
That's what I need. Yeah, that's it. Why do you want me to come talk to you again?
That's great. That's great. Yeah, lock that in. I love those moments in my own life for sure. Well, this has been really, really interesting. Thank you so much for your time and for being here.
I appreciate it. Thanks, Dan. Thanks for the invite, and thanks for allowing me to talk to your audience.
That was Tomide Adesanmi, co-founder and CEO of CircuitMind. We'd love to hear about your experience working with non-traditional EE tools like this. Let us know on the Moore's Lobby social media pages if you've done it. I'd very much like to hear how this type of work is going for you. And also, if you know anyone who would like this podcast, please share it with them. That's how we grow and get to line up these great guests. I'm your host, Daniel Bogdanoff. Thanks for listening today, and I'll see you next time.